Hi you all. This is Celso Batalha, and I look like to give a little tour on WebAssign and show all the assignments that have been listed as homework for this semester. They are all closing on Sundays, and just make sure about that. There you go. So the first assignment is supposed to close on Sunday, and every other Sunday that's when the assignments are supposed to close. And get used to the fact we are going to advance one chapter every week. So every week you should be available to complete your homeworks. If you need any help, contact me right away. You can email or you can see me during office hours, either in my office or in Math and Science Tutoring Center. Now, in WebAssign also, you have an option of ebook, or if you purchase the paper book, um, if you purchase the paper book, you can have access to the materials we are going to cover. So usually what I do, um, by in 2 weeks in advance, I will upload a small video in which I will browse through the book, and I will try to highlight important things that you should read and test yourself in a book. So the chapter one, or the first chapter, introduce unities and and dimensional analysis um, and the major part of it is which for some of you is going to be first exposure to, for some others going to be just um, an attempt to remember coordinate system in trigonometry. Okay, so let's take a look at these materials quickly. And so first of all, why unities? Well, because physics is like a window that allows you to contemplate nature. More than just contemplate nature, it allows and enables you and empower you with the ability um, to measure things and predict events. So basically, when we develop theories, either in physics, astronomy, and chemistry, um, and these theories are very elaborate ways to explain what we observe, and these explanations, the way scientists talk about nature, the language of science, employs numbers, mathematics. So this course is an algebra-based course. So you have to be somewhat skillful with your numbers and with algebra, because that's going to be used a lot. Okay, um, but numbers are not enough. So numbers are associated with unities. For instance, 1 second is not the same thing as 1 mile. So mile is a unit of distance, and seconds is a unit of time. Like light year, which is a unit of distance used in astronomy, it's not the same thing. 1 light year is not the same thing as 1 mile or 1 kilometer. So the international system is the one we are going to use primarily in this course. And based on that, distances will be given in meters, time in seconds, and mass in kilograms. Okay, mass in kilograms. So let's keep moving. Now, this is the unity, the system we are going to use primarily, the international system of unity. Area, since is the multiplication of two unities of distance, which is meter. So meter times meter is meter squared. Volume is meter to the third power. Velocity, which is a quantity that is given by the ratio between a displacement and time, then the unity of velocity is meter per second. Acceleration, which is the change of velocity over time, so it's final velocity minus initial velocity over certain time interval. Then we're going to have, for velocity, we have as unity of it meter per second. And if we talking about acceleration, which is the change in velocity over time, is going to be given by meters per second, or meters per second square. So every time we come up with the numbers, so for acceleration as a vector, acceleration will be given by a number which excuse me. All right. So 9.8 meters. Oops, click something wrong. Sorry about that. 9.8 meters per square second. So when you write acceleration, you have to give a number and you have to give unity. If you are writing distance, let's say you walk 1 mile, you have to give number and you have to give unities. Okay. Velocity, or let's not mention velocity, and then probably later I'll explain why. But let's say speed. Oops. Speed. V for speed. That doesn't make sense. Huh? But let's say speed. The speed is 60 miles per hour. So I'm giving a number and I'm giving the unities of it. So when you do your problem in exams or homeworks, don't forget you have to specify what exactly you are you mean. And if you mean later on we are going to learn about energy, for instance, so then energy has a unity of joules, and then when you talk about energy, when you talk about when you oops, when you talk about energy, and you're going to say energy of 60 joules, or 1000 joules, which is a unity of energy. Okay, so which means there is not a lot of there between you. Be careful. Now, on chapter 1, what is the point that I would like really for you guys to pay attention and do some work on it? Coordinate system. So there are two basic coordinate system. One is the Cartesian and the other one is polar coordinate system. So the Cartesian coordinate system is when you want to place quantities on an axis. Y-axis and x-axis, right? So a Cartesian system is one that has two axes. The vertical, if we are talking about distance, is the y-axis, and the horizontal, if we are talking about distance, the x-axis with its proper unit is meters. I could use, instead of distance, I could use a Cartesian system that implies distance in the y-axis and time in the x-axis. So what is the point of it? Well, I can do things like um, I want to describe somebody that moves with a in a Google map. That's a good one. Imagine you have a Google map, y, x, and you want to pin down some location, and in your x-axis you have every single tick mark is given by points in kilometers. Kilometers, 1 kilometer is 1,000 meters. And in y-axis, the same thing. 1, 2, and 3, and so on, so on, so on. So a point in this system, let's say the one that I just represented here, is one that has in the x-axis, and I'm shooting here, okay, 1.5, somewhere between 1 and 2, and in the y-axis, man, that's terrible, it's about 1.7 right there, 1.7. So this point has a coordinate system, is a point with coordinate 1.5 in x and 1.7 in y. Okay, so if you give me a point that is, let's say, 3 and 2.1, and I want to represent this point in my coordinate system, so 3, let me erase all of this. So 3 would be somewhere in here, right? And 2.1, a little bit above 2, somewhere here. This is my point. Point P for Peter, or Paula. This is the point x3 and y 2.1. Okay. Cartesian system. Why is that? Well, I will come up with stories. They will appear in chapter 2, like somebody leaves the house, the origin, and then moves certain amount of kilometers in the east direction. This is east, and this is north. And then it moves certain amount of kilometers in the y direction, and then I will ask things like where is the final destination of that person. So you have to be smart in the sense that you know how to place points in the Cartesian system. The other thing that you really need to be um, good at is your trigonometry. Trigonometry. So what is this? What is trigonometry? Well, trigonometry will appear a lot in the polar coordinate system. So you have your y and x axis. But, oops, I pressed the wrong thing. But what you need to know about trigonometry is this. Here I'm representing a triangle defined by points A, B, and C. In fact, let me do differently. I didn't like what I just did, so I'm going to erase this, and I will erase this. I'm talking about a triangle, so I don't need the whole thing. So here's a triangle, that is given by sides, that's better, sides A. A is the adjacent side of this angle, calling theta. A, B, and C. So B is the opposite side of this angle theta. Opposite because it's in the opposite direction, right? Angle is right here. This is the point. So this is the angle. This is B, opposite. And C, it's called the hypotenuse of this right triangle. Assume this is 90 degrees angle. So A is the adjacent side, B is the opposite side, and C is the hypotenuse. So in trigonometry, and get used to, you're gonna use a lot of this. A function named sine of angle theta. So sine of angle theta is given by the ratio between opposite side B by hypotenuse C. So sine of theta is given by the ratio between this side and this side. Let's say I have a triangle, I will write right here, whose sides are given by 3, 4, and 5. So this angle theta, sine of this angle, is given by 4 divided by 5. Now, what is the second function? And you have to be good at it and understanding well. Cosine. Cosine of theta, cosine of this angle, is given by the ratio between adjacent side A by hypotenuse C. That is the cosine. So cosine of theta in my triangle 3, 4, 5 is 3 over 5. And the last function we are not going to use a lot, but I have to give anyways, it's called tangent. Tangent of angle theta is given by opposite side divided by adjacent side. So tangent is equal B over A, which is 4 over 3. As you can see, tangent is also given by the ratio between sine and cosine. In other words, tangent of an angle is equal to the ratio between the sine and cosine of that angle. So you gotta be good at it. And we are going to see these functions appearing a lot when we study Newton's law and stuff. So I recommend you to, in chapter 1, to focus on 1.7, 1.8. There is an example 1.10. How high is the building? How high is the building? So work on the solved examples 1.10 and 1.11. 1.10 and 1.11. Okay? And that is much for today.